Hello students, I hope all of you are very fit and fine. So students, we are continuing our video classes. In the previous video I have started a new chapter of your class 10 chemistry syllabus, that is acid, base and salt, that is unit 2. So if any of you have not gone through yet on that video, please go through that video. The link is given in the description box, and after watching that part you have to watch this part. So this is the part 2 of our new chapter, that is acid, base and salt. So in the previous video I have discussed a lot of things, that is what is acid, what is a base, what are the main characteristics of the acid and bases, what are the main theorems or theories that is actually present in the market to define what is acid and what is base and these things. Okay, and today's class will be of two major thing. Number one is indicator and number two is salt. So at first, when we are talking about salt is nothing, it is the product which is formed by the reaction of some acid and base. So about this salt I will discuss in this video, but after completion of the part that is indicator. Okay, so after completing the indicator part I will definitely discuss this about this salt. Okay, so at first we are starting today's class with indicator. So start it, just make a heading, what is an indicator? Indicator means which are indicating something. What is they indicating? So at first when we are thinking about indicator, what will be the definition of an indicator? Indicator means nothing. These are the substances which can give different colors or different odors. Odors means smell in different solution. Suppose we are considering A is any object or any substance, any chemical substances or any natural substance. Okay, when this A will be mixed with an acidic solution, then it will give a type of color. Suppose let us say red color formation is here. But when this A is mixed up with a basic solution, this A will give, suppose, blue color. That means what? So A is indicating that this one is acidic in nature, and A is again indicating this solution is basic in nature. By which they are indicating it? By changing their colors. So the substances which can change their color, as well as some substances are there which may change their odor or smell in acidic solution and basic solution. That means in acidic solution their smell may be something, but in basic solution their smell may be different. That compounds or substances will be known as indicator. Is it clear? So now students, you will see some different type of indicator. At first I am classifying the indicators into three different part. Okay, these indicator in three different part. Number one is natural indicator. Natural indicator means the indicators which we can obtain from nature. Okay, like what are the main examples? Suppose litmus paper, okay, after that red garbage, leaves, extract. Okay, that means a solution that will be prepared by red garbage leaves. By extracting that, the solution we will get, that will be our natural indicator. After that, number 3 is suppose flowers of hydrangea plant. After that, turmeric, very important natural indicator, this one turmeric, and litmus is also very important and useful natural indicator. That means these are the indicators which we can obtain from the natural sources. Okay, that means we don't have to make any kind of chemical reaction to get it, we don't have to use the laboratory to get it, we definitely will get these natural resources from the natural indicators from the natural resources. Okay, now moving to the next point, that is synthetic indicators. So from the name you will definitely understand what do you mean by synthetic indicator. That means we have to synthesize some compounds to get this kind of indicator. So very important two synthetic indicator is, one is phenolphthalein, okay, PHENOL PHTHALEIN, phenolphthalein, and the next one is methyl orange. Okay, you have to remember these two, very important in case of acid base titration, in case of various reaction you will use these indicators. Okay, in the practical purpose also you have to use these phenolphthalein and methyl orange definitely many times in your life in the laboratory. Okay, in chemistry laboratory. And the number 3 is olfactory indicators. What do you mean by olfactory indicators? Olfactory, this means the substance which have different order in acid and base. Suppose A is a substance, when it is situated in an acidic solution, then it will give a type of order, and when this A is situated in basic solution, then they will give some different order. Okay, so what are the main examples of olfactory indicators? Vanilla essence. Number 2 is onion, very important and very interesting olfactory indicators. Okay, you know, this onion will give very characteristic smell in acidic solution, but when it is situated in basic solution it will not give any smell. Very interesting one. Okay, so these are the main 3 different part of indicators. One is natural indicator, one is synthetic indicator, one is olfactory indicator. Olfactory indicator means the substances which will give different odor or different smell in acid solution and basic solution. Okay, some vanilla essence, onion. In case of natural substances, these natural indicators are those substances which can occur from natural resources. Suppose litmus, red cabbage leaves extract, flower of hydrangea plant, and turmeric, very interesting this one, turmeric. And synthetic indicator means phenolphthalein and methyl orange. Now see, you will get a screen right now, you will get the total list of indicators with their smell, with their color in different solution in the screen. Right now you have to pause it, you have to write it on your copy, and after that we will continue our class. So right now here your list of indicators with in different solution in different color and order is here. So students, right now you got the chart, and just see one thing. Suppose you got phenolphthalein in acidic solution, this is in acidic solution, this is colorless, but in basic solution, this is pink in color. Very interesting observation you can see in the laboratory also. What actually happens in here? Actually, suppose we are taking an example. Suppose in laboratory, this is a burette. Okay, this is a burette. Okay, this is a stand. This is a burette. Okay, you have you have taken some basic solution, suppose NaOH solution in this burette. In a conical flask, Okay, in a conical flask you have taken some acid solution, okay, you have taken some acid solution. We know when we will start to drop or to allow the basic solution present here to come over the acid solution, then a reaction will take place, and we know when acid plus base will react, they will produce salt and water. Okay, I will talk to you about it in later. Just you know that this is the basic thing, that acid plus base will make salt plus water. Now what the things are going on here, suppose these basic solution are coming to the acid solution, okay, but when this acid solution will completely neutralize means at the point when no more acid present in this solution and the amount of base will be more. Right now suppose this is, let us assume, suppose 50 acid molecule is present here, and we are dropping some basic solution from here to here. Suppose one base came with one acid, they will produce salt. So now acid will remain 49. After that again one base will come, one molecule of base will come, and it will take another acid, and now acid is 48. After that 47, 46, 45, and like this a certain point will come when that mean only one acid molecule is right now present, and when one drop of base solution will come at this point, then there will be no more acid solution is present in this mixture or in this solution. Okay, but after that if we again make a drop or allow a drop of base to it, that means this solution will become what? This solution will become basic, but we don't know when it will come. So to find out that particular neutralization point when no acid solution is present and no basic solution is present extra, okay, to find out that moment, to find out that point, we have to use before the reaction some indicator, and we know when this is acid solution, phenolphthalein is used as indicator. If phenolphthalein is used as indicator, then it will be colorless. So in this colorless acid solution, if we give 2 to 3 drops of indicator, then no change of color will happen here. Okay, no problem with that. But right now we are allowing this basic solution to mix with this acid solution, and after a certain point will come when no more acid solution is present in the solution, and when one single drop of or one single molecule of basic nature solution is here maximum than the acid solution, then the nature of this solution will be basic, and we know the color of phenolphthalein indicator in basic solution is pink. That means at that very moment when the solution turns into what? It turns into pink color, then we will definitely understand that our neutralization process is over. That means no more acid solution is present here. That means right now we know this solution is basic. So to find out that particular moment when the neutralization process is finished, to know that value, we have to use some indicator, and after that we have to calculate that what ml of basic solution is needed to neutralize this acid solution. So I think you have clearly understood what I want to say, that why phenolphthalein or methyl orange is used as an indicator in the acid base titration. Okay, so you know turmeric, that is a natural indicator. So I am giving a clip to you to know how the turmeric solution or the turmeric powder is used as a indicator. So now just I am playing this video, you have to watch it.
Lemon juice, which is acidic, soap water, which is basic, 2 clean small empty bowls, and droppers. Take a little bit of lemon juice in one bowl. In the other bowl, take a little bit of soap water. Add a drop of turmeric solution into each bowl. Observe the color of each solution. Adding turmeric solution in soap water changes the color to red-orange. We see no change in the solution of lemon juice. Turmeric is an indicator that only changes color when added to a base and has no effect when added to acids. Now add lemon water, which is an acid, drop by drop into the solution of soap water and turmeric. Shake the solution well after each drop. As you add the drops, observe the changing color of the soap water. Stop adding acid when the color of the solution regains the color of the turmeric. As the amounts of acid and base in the solution became equal, the solution ceased to be either acidic or basic. At that point, the solution became neutral.
So students, I think you have completely got the full knowledge what the indicator actually is, why the indicator is used in the chemical reactions and like this. So now we are moving to our next part, that is salt. So this is a type of reaction when acid is reacting with base, it will produce some salt and water. This reaction is known as neutralization reaction. Okay. So in the previous class, we have discussed strong acid, strong base, weak acid, weak base. So 4 different type of neutralization reaction will be there. Number 1 is when strong acid will react with strong base. This is a type of reaction. When weak acid, that means weak acid with weak base, that is a type of reaction. Now strong acid but weak base, that is a type of reaction, salt plus water. And then weak acid but strong base, that will be a type of reaction. So in these 4 different type of reaction, we will get 4 different type of product. When we are taking strong acid and strong base, so no problem with that, normal neutralize salt and water, and weak acid and weak base, normal neutralize salt and water, no problem with these 2. Okay, but when it comes to the strong acid and weak base, so definitely in that solution, the solution will be of what nature? Yes, acidic nature, because acid is strong here, so the salt will be some acidic salt. Okay, and in this case, when weak acid with strong base is here, then as strong base is used here, so the salt will be some basic in nature. So 4 different things are there. So in this neutralization process, suppose we are taking NaCl, sodium hydroxide, okay, plus HCl. What will form? Sodium and chloride will be sodium chloride salt, and this hydrogen and OH will form water. So this is base, this is acid, this is salt, this is water. This type of reaction will happen. Suppose here NH4OH plus HCl. Okay, this is weak base, and strong acid, okay. Then what kind of thing will be there? NH4Cl, this NH4, this Cl, and this one is water. Okay, water, as this is what? This is strong acid, so this is some acidic salt, NH4Cl. Okay, now the thing is that for this 4 type of neutralization reaction, we know indicator is used to find the neutralization point, and students, you cannot use any indicator for weak acid and weak base, because as both are weak, so the neutralization will take place a long time and you will not find the actual neutralization point. And in case of strong acid and strong base, you can use any indicator, maybe that is phenolphthalein, maybe that is methyl orange, any indicator. But in these two type, some specific conditions are there. So in this case, when the acid is strong but the base is weak, in this case methyl orange indicator will be used. And in this case, when acid is weak but base is strong, in this case phenolphthalein indicator will be used. Just remind it that strong acid and strong base, any indicator, okay. Acha, which pH value is 4 to 10. What is pH? I will talk to you later in this matter, regarding this matter, because in the next video or the video after the next video, I will discuss what is pH. And this one is weak acid and weak base. No perfect indicator is used. And in case of strong acid and weak base, that is methyl orange, and in case of weak acid and strong base, phenolphthalein indicator is there. Okay, so students, if you want to write some example of this, suppose strong acid, strong base, that means HCl plus NaOH, okay, HCl plus NaOH, this is strong acid, this is strong base. What will form? NaCl plus water. Okay. Now weak acid, weak base. Weak acid, weak base means suppose oxalic acid and NH4OH. Okay. Weak acid is oxalic acid and weak base is, suppose weak base is NH4OH. Okay, very good. Now strong acid, weak base, this one HCl plus NH4OH, strong acid and weak base. And weak acid and strong base, that is a very important. That is, suppose weak acid means CH3COOH, that is acetic acid, and strong bases means suppose NaOH. Okay, so it will form CH3COONA, CH3COONA, and this one is water. Okay, this one is water. So these are the different examples of different neutralization process. I hope all of you have understood this one very easily. So in today's video we have discussed a lot, that is what is neutralization reaction, what are the indicators, what do you mean by indicators, in which cases indicators are used, what are the main mechanism of indicators, what are the different types of indicators, after that what the indicators are used in these different type of neutralization reaction. All the things are cleared. So in the next video we will discuss about the reactions performed by the acid and bases. Okay, so before that you have to complete the video part 1, and this video, that is part 2, you have to complete it, you have to write it on your copy, and after that we will start the next video. Thank you so much, and we will see in the next video. Stay healthy, stay safe.